This video is the first part of two total in which I'm going to be solving equations with variables on both sides. So in my first equation I have 2b minus 5 equal to 8b plus 1. Our variable term, which has b in it, is on both sides of the equation. Now if you recall, it's helpful for us, and our goal is to try to make sure our variable stays positive. If it isn't, it's not a crisis, we can fix it later. But if we can try to make it positive initially before we actually start solving, then it helps us later on. So in this example, if I were to move 8b to the left side of the equation, my variable term would actually end up being negative, because I know my inverse is still would be minus 8b, and then 2b minus 8b would leave me with a negative number. So I don't want to move 8b to the left, but if I move 2b to the right, I can see that this would be a negative for the inverse operation. So 8b minus 2b would actually leave me with a positive answer. So that's what I'm going to do. So now I'm going to go ahead and write my problem down. So notice what we just did. We just did our thought process. We just determined, okay, what's our line of attack? What are we going to do first? We know we need to move a variable term over in this case. We don't have to distribute. We don't have to worry about anything like that. So I'm going to do the inverse of positive 2b. Well, positive is like addition, so the inverse would be subtraction. So right here I have 0, and then I'm going to subtract 2b here. Notice I'm not subtracting it from 1. I'm subtracting it from 8b. It has to subtract like terms. We're basically combining like terms by using inverse operations. So 8b minus 2b is actually 6b. So now my problem looks like this. This is minus 5, so it actually is minus 5 equals 6b plus 1. Now my b is on this term, on this side, so I'm probably actually going to need to move my 1 over to the left, because we were trying to isolate our variable. So since this is adding 1, my inverse of addition is subtraction, so I'm going to subtract 1. So of course this will become 0 because they're inverses, and then a negative 5 minus 1, if I don't remember, I'm going to write it out. Negative 5 minus 1, that's the same as doing, if I use my little addition and minus, a negative 5 plus a negative 1. So actually my answer is going to be negative 6. So right now I have negative 6 equal to 6b. So now I need to isolate my variable. So as we learned before, we can actually use our commutative property to rearrange these. But actually what I'm going to do is rearrange the entire problem, so my variable term's on the left, just so it's easier to see. So I'm going to rewrite it. I have to be very careful when I do this. I have to make sure I don't forget any signs or anything. So my coefficient on b is 6, so I'm going to multiply by its reciprocal. And I'm going to do that on both sides. So I'm going to get, right here, I'm going to get 1. So I'm left with b equal to, and then over here I'm going to end up with a negative 6 over positive 6, which is just negative 1. And that's it. So to recap, we first had to decide which side we were going to move our variable terms on. In this case we decided to move them to the right. Then I decided to move my constant term to the left. This is what I had, and then I switched it. So now if we think about it, I could have actually moved my b term to the left. I would have ended up with a negative, right? But at least my b term would have already been to the left, so it would have been negative at that time, but it's not a big deal, because when we would have had to do this, the reciprocal method, I would have just ended up multiplying by a negative instead of a positive. So either way, we still would get a negative 1. Now, in this problem here, I have to do this distributive property first before I can even consider which way I'm going to be moving my terms. So let's go ahead and do that first. So here's my problem. Now before I distribute, if we notice this is subtraction, so I'm actually going to go ahead and change that into addition. So here's this side still. So it's going to be 4m, and if you remember, I'm going to put it over here, whenever we subtract, that's the same as adding the numbers inverse. So this is actually going to be plus a -5. So now, let me go ahead and rewrite my left side again because we're not changing anything yet. Let's go ahead and use our distributive property. So we're going to have 2 times 4m, which is 8m. And then we're going to have 2 times a -5, which is -10. So as our problem on the left here, we have a similar situation. We have more of our variable terms on the right side than we do the left side. What I'm going to do now is I'm going to illustrate what we could have had in this previous problem. Over here we wanted to move everything to the right to keep our variable positive. Well, what I'm going to show you is what happens when we move it to the negative. It will still work out in the end. So I'm actually going to subtract and move 8m to the left, even though I know I'm going to get a negative coefficient. So this is positive 8m, so that means my inverse would be minus 8m, so this is 0, minus 8m here. So 3m's take away or subtract 8m's actually leaves me with -5m's. So my problem now looks like this. What I can do now is move I'm subtracting 10, so I'm going to add 10 because I want to move this over there to the right now. There's 0. Add 10. So now my problem says -5m equal to 0. So now this is what happens. See how our variable term has a negative coefficient? Well, it's not too big of a deal because we know we're going to multiply by its reciprocal. So the trick is since it's a negative reciprocal, we have to make sure we multiply by a negative number. Since our coefficient is negative, we have to make sure our reciprocal is also negative because our goal is to get a positive 1, which we do. Got to multiply over here. So we still end up with m, but this time 0 times -1/5 is just in fact 0. And 0 can be an answer. If we were to substitute this back in here, we would get a solution. So notice on this one, number 2, we had to use distributive property first before we could start combining like terms. And over on number 1, we could go and start combining like terms after we figured out which side to move our terms on.